All right, let's review some of the notes that we completed on 2.2, which is proving angles congruent. And we have one key theorem today, and that'll mostly be it. So, a theorem is a statement you prove to be true. It's different from a postulate because a postulate is a fact and it's just known to be true, but a theorem is something you actually have to prove yourself. And how do you do that? Well, you use reasons. And what are reasons? It could be given info. We use that for every proof. It could be a definition. It could be a property. It could be a postulate. Or it could be other theorems. And these 5 things all come together, and we use them as reasons in the 2-column proof. And these are all on magnets that I have in the classroom. Okay, so we've talked about vertical angles before, but we haven't shown that they're congruent. So here's a proof that can do that. Okay. So first things first, copy down the given. So to show that 2 angles are congruent, you're going to have to make some sort of angle pair. And we know we want to get to vertical angles, but we can't quite say that yet. So how about maybe some supplementary angle pairs? How about angle 1 and angle 2? They're supplementary, right? Because they form that 180-degree line. And the same is true with 2 and 3. Okay. Why do I know these are supplementary? Well, because the picture tells me. Because they're linear pairs. Okay. Now, if we want to get into an equation that has the congruent symbol, we got to use the word supplementary and convert it to something else. And the definition of supplementary angles is that the measure of angle 1 plus the measure of angle 2 equals 180, and the same deal with the other angle pair. Okay. Now, this is getting me closer because at least I have an equation, and then the prove is that I want to get this. So I'm trying to get there. So I notice with these 2 equations that we can actually combine them together. Because remember, we want to make a statement about 1 and 3. So 2 is kind of like the middleman. So one thing I notice is that measure of angle 1 plus measure of angle 2 equals 180, and 180 equals the measure of angle 2 plus the measure of angle 3. So this kind of bridging together of 2 equations is the transitive property. Okay. And then notice that both sides of the equation have a measure of angle 2. So I want to subtract that from both sides. By the subtraction POE. And then we have our good friend, our conversion between the equal sign and the congruent symbol. Conversion between measures of an angle and the angle itself. That is, congruent angles have equal measure. is that conversion piece between equal sign and congruence for angles. And there you have it. We proved it. We proved that these opposite angles like this are congruent. And it was basically just because of supplementary angles. Okay? So with this fact, we can answer questions like this. Because now we know that vertical angles are congruent. So I can set this up right away. And we've done plenty of these little equations. And there you have it. Another type of question we can solve. Now, this one's the same deal. I want to link the ones that only have x's, because then I can actually solve it. So I'm going to do some moving around, and you can pause the video if you want to copy this down. Right. So if that's 14, we still need to find y, which belongs to this term. But I know that by supplementary angles, 3x plus 8 plus 5x plus y, 4y, is 180. Right? And now if I go through and, how about, let's get the variables on one side, numbers on the other. I know what x is from before. And that would be what? 111? 112? Yep. Kind of a bit of work, but we're just setting up supplementary angles and solving, plugging in what we know. Okay. So a more complicated picture, but we just applied vertical angles and then we applied supplementary angles. Okay. This is a good one, just a quick one, just to get us remembering what vertical angles are. This 90-degree angle is vertical to angle 1. Okay. Remember, it makes that x, and it's the opposite sides of the x. So if I erase one of these and fill in this one, I'm not talking about that. Oops. I think I erased the wrong one. Erase this one. Now you see that angle 2 goes with 50. And if I erase this one and visualize this, 3 is 40. That's it. We're just saying that opposite, if you call opposite angles, that's okay, but it's vertical angles are congruent. All right. Now, we have a different type of question here, and these aren't necessarily about vertical angles, but they're about solving equations about complementary and supplementary angles. So it says angle C, or the measure of angle C, is twice as large as its supplement. Find the measures of the angles. Okay. Well, I always pick the angle that comes second. I want to call that x. So angle C is equals twice, 2 times x. Okay? And then since angle C and angle D are supplements, the measure of angle C plus the measure of angle D is what? 180. So 2x plus x equals 180. 3x is 180. X is 60. So to conclude, the measure of angle C is going to be double that, and the measure of angle D is 60. And they do add to 180, so that makes sense. Okay? So a couple more questions like that. I'm going to take this second one. I want to call that X. It says the measure of angle A equals 20 less than, which is a minus sign, its complement. So if we're 20 less than X, it's X minus 20. Because it's the value of X, but take away 20 from it. Okay? But angle A and angle B are complementary. So if you add them up, you should get 90. So just go ahead and plug in what we know. And then we get that X is 55. So to conclude, the measure of angle A is, well, the measure of angle B I know is 55 because it's just X. And then if you don't want to look back on your work, you know that these have to add to 90, so it has to be 35. But that's also true because it's equal to 55 minus 20. Okay, and last one here, so we'll say the measure of angle B is X. The measure of angle A is 3 more than, is always 3 plus, half B. Three more than half of B. But they're complements. So if you add those up, the formula is a little bit more complicated, but oops, this is equal to X, isn't it? So we get what? 1.5x equals 87. Let's make sure that's right. I think we get x is 58 from that. Yeah, that seems to check out. You could have also multiplied that whole equation by 2. But in any case, the measure of angle A, measure of angle B. B is just x, so this is 58. And then A must be, this has to add to 90. So I know for a fact this is 32. Or you could plug back in 58 into this equation. Okay, so pause if you want to write that down or have questions. And please bring your questions to me if you watch this and you aren't sure on how to do these. A linear pair, we know as supplementary. Those words are like interchangeable. So the measure of angle 1 plus the measure of angle 2 equals 180. I know that from just the first sentence. And then it wants me to plug in what we know, substitution, and then just solve the little equation. Y is 6 there. So linear pairs are very straightforward. You know, they just equal 180 together. Okay. And then I want to end on just one more proof. So the given is already typed in here for us, so we can kind of scroll down. We want to prove that x is 10. Can slap that down there. Okay. If we aren't sure where to proceed, it might make sense to draw a picture. So A, C, B, B, C, E. This one is that. This one's that. Okay. So we know that we just did a problem like this. You're supposed to just add them up, set them equal to 180, and solve for x. Okay? But we don't know from the word linear pair that it just directly means add to 180. There's an intermediate step, and that's why we have this magnet here. Linear pairs are supplementary. Okay? And that's all we have. We can't just jump freely from whatever we want. All we have is the conversion between a linear pair and angles being supplementary. And on a test, you would get some help with some of these filled in. But because the expectation is not for me to go from, like what we're doing now, like blank proof, fill it all in. No, you'll have stuff filled in. But trying to give you the reasoning why. We know we want to get to 180, but linear pair is our vocab word. So that has to come next, and we don't know linear pairs of 180 immediately. So we have to write this. And then now that we have the word supplementary, then we can use the definition of supplementary angles, which we know involves the fact that these are equal to 180. Okay. Once you have a nice, beautiful equation with an equal sign, you're typically going to substitute the next step to solve. And this is the step we jump to in this question. But we did say this first, and that's by the definition of supplementary angles, but also the fact that linear pairs are supplementary. So stick this in here, and then you're kind of in the clear. Just solve the equation. So combine like terms. Oh, yeah, combine like terms. That's what that stands for. I'm just solving equations like I normally would, and then supporting it. So addition POE and division POE. There you have it. Okay? That's everything. Please come talk to me if you have questions about this. Thanks for making it to the end of the video. You're going to do great if you're watching these videos.